Welcome. This presentation explores how ideas evolve into systems, into databases, and ultimately into intelligence. It is the blueprint for transforming abstract thoughts into adaptive machines. Before code is written, there must be specification. Before specification, there must be clarity. We will examine three foundational questions. How do we translate vague intuition into executable engineering specification? How does system behavior crystallize into structured database and architecture? And how does stored data re-emerge as adaptive intelligence? This progression forms the stack: idea, system, database, intelligence. Understanding this stack is the difference between building software and engineering intelligence. Intelligence architecture emerges across four layers. The idea layer decomposes ambiguity into defined constraint. The system layer separates structure, what is, from behavior, what happens. The database layer preserves persistence. It is where the system's worldview is stored. The intelligence layer closes the loop, using memory to predict and optimize future behavior. Each layer depends on the structural integrity of the one below it. An idea is a raw signal without schema. It lacks defined boundaries. It lacks explicit inputs and outputs. Engineering clarity begins when we stop treating ideas as inspiration and start treating them as undefined specifications. An idea answers what. Execution determines how. They must be separated immediately. The moment we define dimensions, inputs, outputs, limits, we transform signals into specification. Every viable system evolves through three stages. First, the idea, vague emotional intent. Second, the problem, a measurable and specific obstacle. Third, the solution, an executable engineering mechanism. For example, I want an AI that helps people learn from videos. This is an aspiration. User cannot query video's content because video is unstructured data. This is a defined gap. A system that indexes transcripts and retrieves context-aware answers. This is architecture. Maturity is the movement from emotions to mechanism. Ideas must be decomposed. First, principle thinking reduces the concept to irreducible truth. Abstraction hides complexity behind interfaces. Systems boundary thinking defines where the system ends and the environment begins. Decomposition fractures a monolithic into functional modules. If the concept remains monolithic, it remains unbuildable. From ambiguity to engineering clarity, the template. If you cannot fill this template, you do not yet have a buildable idea. Who acts? What is desired state? What feeds the system? What does the system return? What constraints govern it? What metrics define success? Clarity precedes construction. Without defined constraints, there is no architecture. A system is a set of interacting components within a defined boundary. Input enters, component interact, outputs emerges. Boundaries determine responsibilities. Interaction transforms data and controls signals. Software operationalizes the problem defined in the idea layer. The system is the machine that executes specification. The crucial distinction: state versus behavior. State is the noun. It is data stored at rest, memory, behavior is the verb. It is the logic manipulating data. Intelligence, state persists, behavior executes and disappears. Intelligence emerges from the interaction between persistent state and transient behavior. Without state, behavior forgets. Without behavior, state stagnates. The architecture blueprint, YouTube AI assistant. The architecture forms a pipeline: user, front-end, back-end, AI engine, database. An AI engine receives user query and transcribes chunks. It performs inference. The database stores vector embedding of video content. This is the moment where behavior, user intent meets state, stored knowledge. Architecture is now operational. Why every system becomes data. Systems terminate, data persists. State must survive the process. Persistence enables analytics. Analytics enable optimization. Optimization enables learning. The database becomes the fossil record for behavior. It captures the history from which intelligence will emerge. Modeling reality. Architecture must crystallize into structured entities. In relational systems, user connects to view, connect to video. This enforces consistency and safety. In NoSQL systems, documents store video ID, title, transcript, timestamps, comments. This allows flexibility and rapid iteration. The modeling choice determines how memory is retrieved. We must identify the noun, user, video, timestamp from component to entities. How machine learning uses structured data. Machine learning transforms historical data into predictive capabilities. Raw database entries becomes features. Correct outcomes becomes labels. Training iteratively minimizes error. Prediction generates feedbacks. Feedback returns to the database. Intelligence is not a magic. It is the statistical compression of the database history. Memory in intelligent systems. Intelligent systems maintain layered memory. Episodic memory stores specific interaction over time. Session 1, Session 2, quiz failed. Semantic memory stores generalized knowledge structure. Algebra connects to linear equation. Linear equations connect to triangle problems. An adaptive system uses episodic memory to track context and semantic memory to retrieve structured knowledge. Continuity enables personalization. Adaptive loop reinforcement learning. Reinforcement learning formalizes adaptation. State represents the environment, action modifies it, reward evaluates the outcome, policy update adjusts future behaviors. The goal is to maximize reward over time. The database stores reward history. From that history, policy evolves. This is intelligence as an adaptive loop. The full stack of structured intelligence. We now see the full structure. Idea becomes specification. Specification becomes system. System becomes database. Database enables adaptive intelligence. Core principle. Ideas are specifications, defined inputs and outputs before writing code. Separate state from behavior. Data is density. Your AI is only as strong as the schema that captures its word. Close the loop. Intelligence is the ability to use past data to optimize future behavior. We are not merely building features, we are engineering intellectual infrastructure.